I do not like the debt metaphor. Just generally think it's not helpful in helping you make a decision about what to do. Like whether or not you took a shortcut is not really germane to the decision. And I actually think a lot of what we call tech debt doesn't come from a shortcut. I think it's actually a very rational decision at the time to do what's appropriate at the time for the learning, for product market fit, for the size of the problem, or for your knowledge of the problem. And I think that what happens mostly is the world changes, or your ideas change, or you just get the scope of what you're trying to do changes, or you get more users. And it's not that you took a shortcut and now you owe it back to pay it back. I don't think there's any obligation. That part of the debt metaphor really bothers me, the obligation. And then the other part is the intention. Like you did it intentionally, which is I don't think true. And generally I don't think it helps.
I'm your host, Rathwan, author of the book Data Impact. Welcome to SLASOG, Leaders or Readers. Here I speak with outstanding operators and seminal thinkers to unpack first principles system rethink for data-driven value creation. Hi, Lou. Welcome to SLASOG, Leaders or Readers. This one's great because we actually were crafting and writing our books around the same time.
Right.
And you're a seasoned technology leader, and you're the first technology leader to come on this pod. And so I'm really excited to have you here. You've just published your book, Swimming in Tech Debt. And
Yes.
we kind of anchor our conversation around that and around your learnings and insights from your long career in engineering. So to kick it off, my favorite question, what's your fundamental disagreement with the status quo and why did you write this book?
Right. So thank you for having me. It's so great to be here, Ridvan, and I'm really looking forward to this. I love that question because it's kind of how I open the book. So if you look up any definition of technical debt, it's going to say something about developers took some shortcuts and the system that they developed worked okay at the time, and now something has happened, there's been some growth or whatever, and they now owe a debt. And that the system as it exists is bearing interest payments, and then you're either going to pay the interest if you don't pay the debt, or you're going to or you could pay the principal back. That's what the debt metaphor kind of means. And I do not like the debt metaphor. I just generally think it's not helpful in helping you make a decision about what to do. Like whether or not you took a shortcut is not really germane to the decision. And I actually think a lot of what we call tech debt doesn't come from a shortcut. I think it's actually a very rational decision at the time to do what's appropriate at the time for the learning, for product market fit, for the size of the problem, or for your knowledge of the problem. And I think that what happens mostly is the world changes, or your ideas change, or you just get the scope of what you're trying to do changes, or you get more users. And it's not that you took a shortcut and now you owe it back to pay it back. I don't think there's any obligation. That part of the debt metaphor really bothers me, the obligation. And then the other part is the intention. Like you did it intentionally, which is I don't think true. And generally I don't think it helps. So what I am trying to do is replace that with a resistance metaphor. And that's where swimming in tech debt comes from, that you're swimming upstream, you're swimming against the flow of the water. And it's got two parts. One, it's pulling you back, but also it's invisibly pulling you back to people outside of the water. Like when they're looking at you, all they're seeing is that you're slow. But you, the developer in the code base, or you, the technologist dealing with the technology who understands the internals of it, you feel the resistance. And that feeling of resistance, I would say, is helpful if you think of it this way, because it points you in the direction of that triggers you to fix the resistance. And now you know that you will get back some benefit, the developer productivity you'll get because you're encountering the resistance. So you're dealing with it at the time that you should. And so I just think it's a more useful metaphor. And I try to bring other aspects of that throughout the book, but that's the central thing I'm trying to say.
Okay, there's so much to unpack here. So I'm totally with you about this flawed debt metaphor. That's exactly how I was introduced to this idea of tech debt. And I was a non-software engineering CTO. I came from the data and math side. And so if you sort of enter the field laterally, or you're not you're not grown up in the field, then you, of course, you go to the basics, you go to the foundations, and you read up these concepts. And of course, if you have a flawed lens, it does not matter how smart or how driven you are, you're going to end up in the wrong place. And so like where did this flawed lens come from? Like, how do you think this became such an awesome
It's interesting because it's not from the source. So the original tech debt metaphor is Ward Cunningham, and it's in the early 90s. And he was working on a system. It was a financial system, and they had modeled that system in what the way they had thought was best. But then they grew to understand that their model of the system didn't match the reality they had figured out later. And he needed to explain to his boss how that was harming their work. And he came up with this debt metaphor, thinking when I'm explaining to business people, it's a good idea to use things like debt, they would understand that. But if you read what he said, or if you watch the conference talk where he explained what he said, it was much more about like what I'm saying, where like everybody was doing things to the best way they knew how all the time. No one was taking a shortcut. No shortcuts were taken. The code perfectly implemented the wrong reasoning that they thought was correct. And what they were dealing with was interest payments and so forth. Like that part kind of does work, and I do use that part. Like, so I call it resistance and volatility. So resistance is the size of the payment, and volatility is how often you're paying. That is part of what when I break down tech debt, I break it down into 8 dimensions. That those are 2 of them, but there's more to it than that. And so I don't think it's from the source. I think it's something that, like everything, like every word that gets coined that is popular, I think starts to, like, vibe coding is the current thing that's happening to. Like, so I think it gets taken by the community in some direction that seems right, and then you can use it as a pejorative to, like, oh, that code, it's a bunch of shortcuts, it's a bunch of hacks, we need to fix it or whatever. Like, it's easy to say that in a meeting and get some emotional reaction, whereas I think, like, saying something is a shortcut doesn't tell you anything about what you should do. I like to take shortcuts when I drive, and they get me there faster. They're not necessarily bad, but yeah. So I think it's just like the community takes it over, and for better or
Yeah,
for
and
worse.
it's
Yeah.
Yeah, I mean, so many of these sort of, anti patterns are just, something that's very easy to grasp and
Mm.
gets
Mm-hmm.
thoughtlessly repeated, right? I think
Yeah.
that's the bane of so much. And like you
Yeah.
said, if the shortcuts were a thing, right? I mean, aren't we all incentivized to, and aren't we all constantly asked to take the shortest route? So like, what's the problem
Right.
there? Like,
Right.
so of course that does not hold up to any amount of scrutiny.
Right.
But then how you kind of reframe it, I think, as resistance when you're swimming. And I think there are 2 points that stood out. I mean, one was that it's about understanding the resistance when you're swimming. And the
Yeah.
second part is the water is transparent, or no one, someone outside the water does not understand how much effort you're putting in. So would you
Right.
like to unpack both of these, and
Sure.
why they're important, and how sort of business leaders, both tech and non-tech, should sort of think about this
Sure.
metaphor?
So, the resistance part is something that, another thing I try to say to engineers is that you probably shouldn't talk about that too much with people who are not engineers, because it's kind of boring and kind of beside the point. Uh, it's not the business result, right? One of the things you often talk about, like, at the end of the day, you have to win the game. At the end of the day, you have to win the battle, right? If you're in the military, and it's like that part, that dealing with the resistance part, it's a totally internal thing. It has almost nothing to do with uh, uh, the business result. It does have to do with developer productivity, which is certainly something you'd want, but these are all internal processes. The other part where people, and people can't see that if they're looking at it. So what you should do, I say and argue, is to try to couple what you're doing with the things that are visible and the things that they do want. Sometimes those things kind of are the same thing. The same fix does both. So that's the part you talk about. So I talk about, like, I worked for the electrical grid and ISO in the US, which is a nonprofit that governs the electrical grid. And we had a project to totally rewrite a very broken system with a lot of, let's call it dead. It was just written in it was written in the technologies that made sense at the time, not a shortcut, right? Like, and then we needed to rewrite it in something more modern. If we did our job right, no one would even know, right? Like, but what the management did, which was I think very good, is they coupled that project together with a refresh of the entire website where the data was published. So that's the way that most people thought of the project, this refresh of this UI. The engineering management totally understood what we were doing. Of course, they wanted us to do it for reliability reasons. But when you talked about it to the public or talked about it to the members of the ISO, what they were going to see was a new publishing system that was modern and refreshed UI. And also its internals would be much better. And that part was more internal. Like we didn't talk about that as much with our stakeholders. And then what happens is once you have delivered it and once it has been successfully more reliable over time, now you can talk about other things they got from it after you've delivered it. Not as a reason to deliver it because they might not agree or understand or fund that. Again, I would say internally we had totally understood this, but not every stakeholder would totally understand that. But afterwards, they do understand reliability metrics that you're getting. So I definitely think making things visible or coupling things that are visible is a good way to get support on these projects.
So I think there are two things you said there, which I think are very useful for anyone, which is that, when you're working in technology, then don't go around whining about your problems because you're the one swimming.
Yeah.
You're feeling the resistance. The person standing on beside the water does not know that. So
Yeah.
don't go and tell them about what you're feeling.
Right.
Instead, try to understand what they are trying to achieve, what everyone else is trying to achieve, and map what you need to change
Yeah.
to reduce the resistance to that. Correct? If
Yeah.
you do that,
Oh, totally.
then you're more successful.
Absolutely. One of the things I heard an analogy once where someone was talking about like when a surgeon comes out of the operating room and tells you, the operation was successful or whatever. They don't tell you like, oh, and by the way, I washed my hands before the operation and that's a good thing to do to reduce infection. Like, yeah. Like of
Yeah.
course. like,
Or,
but did it
yeah, or
work?
when I
Like
was cutting up this, with my scalpel, then I ran
yeah,
into this technical,
it's
detail.
like
No one can.
you already have permission to do what you need to do. Like now, is my whatever my problem was it solved? Yeah, that's what I need to know.
Yeah, or a pilot on a long flight, chatting with you every 10 minutes saying, okay, so now I just switched on this and I just did
Yeah,
that. No one cares, that's your job.
yeah,
And I think it's the
yeah,
same thing what you're saying is basically, just you need to have the maturity to understand the resistance you're facing, and then you
yeah.
should through the trouble to sort of map it to what other people understand and need to hear.
Right.
And then that's a much better frame of going about it. Yeah, before we sort of unpack some, these insights that sort of flow from your reframing, let's
Mm.
perhaps just shine the light on you.
Yeah.
If you could share sort of your life
Mm.
story in short, right, through the
Sure.
critical sort of, or like through these milestones that shaped you for who you are.
Yeah.
That would be great. You worked in legacy businesses. You worked at fast growing technology companies. You've been
Yeah.
everything from, founding engineer to CTO. And so I think
Mhm.
you have a lot to share there.
Yeah. So thank you. Yeah. So I was introduced to programming in middle school in the 80s in New York City. And we were lucky to have a Commodore PET computer. It was, I think a 4K green screen, computer booted into BASIC. And I learned how to program on that and luckily was able to get at home an early PC, like a TRS-80. It was a Radio Shack computer people might be familiar with. I think it cost $50 because it was like several years old at the time, but it was enough to learn. And I was very passionate about my hobby of programming. I did not in any way ever think it was a job. And when I went to college, I decided to major in electrical engineering because I did not think computer programming was a job.
Did others also see it that way, or was it just you seeing it?
I don't know. It was mostly in New York. What I had mostly heard of it as there was IT. The banks
Right.
all have IT, but like writing, there was a company called Microsoft that did that in Seattle. Like, and there were probably. I mean, I just didn't know. I guess there was games, but I didn't necessarily want to do that. But like the idea that there was like that you could have software as a job didn't occur to me until partway through college, and I changed my major, and I have more of a still an engineering degree. They didn't have computer science in at my school at that time, but engineering with a ton of software development classes and mathematics. And then I went into fintech because I was in New York City. So I worked for a company that made foreign exchange options trading software. I did that for a while, then went to a more of a startup that started as a risk management software consulting company, and we eventually made a product that got VC funding and like spun out a small software company from that. When I left there, I went to the ISO as I talked about. I worked in electrical grid market pricing, so still kind of in this bordering on fintech stuff. But then when I left the New York City area and I lived in Massachusetts, I ended up working in for a startup that was in the digital imaging space, SDKs for net developers, and so this is processing scanned images. So bringing in TIFFs and then processing for barcodes or OCR or doing any number of image processing. And then I went from there to Trello. I worked at Trello on the iOS products and then through there to Atlassian. So, and at various places at the startups, I was often in the leadership role there. So either, like I said, a founding engineer at the SDK company, I was the head of engineering. And then I would end up in the acquired companies, management structure at some point and would stay there for a few years until I got the startup bug again and went back.
And yeah, what's the story with Trello and Atlassian, and how did that
Yeah,
go about? And
sure. So I joined Trello just as it spun. It was incubated inside of Fog Creek. It was I think like developed during internal hackathon, and then it kind of took off in 2011 to 2014. Before I joined, they got to about 6 million users and decided to spin it off. Took VC money and spun it off, and then did a little bit of a hiring push. And I was part of that first hiring push. So when I joined, it was still less than 20 people, maybe, and mostly engineers. So maybe like 10 to 15 were engineers, and I was on the iOS team, and I did that and then that was 2014, and then 2017 we were acquired by Atlassian. By that time, we were now hundreds of people and much bigger. We had solved to some extent our revenue. When I started, like I think we were, we had some revenue, but mostly that got solved in the time I was there. And then Atlassian took us in, and we were one of 18 products now, and then I stayed there for 4 years inside of Atlassian, and we grew, maybe, I don't know, maybe doubled in size in that time, but in people and more than that in users. But it was very interesting to see the inside of Atlassian. They talk a lot about their internal, like how they run things, and it is what you see, what they say it's pretty much what I saw. It follows like I think the model that Spotify popularized, where teams are independently deciding how to manage themselves, and that was the case on Trello. Our iOS team didn't follow the processes of like other Trello teams. We were closely aligned with the Android team because we all worked together on mobile, but generally people ran their own kind of internal processes, and it just like makes it a lot easier to move faster in the space that you're in. And then there are other things that cause cohesion across the products, like different
what were
processes.
those things, and like how did they manage cohesion? Because you go from
Yeah.
1 to 18 products, right?
Oh yeah, I mean across all of Atlassian, even just within Trello, right? So like there's cohesion within. So I was one of, I don't know, a dozen, maybe more teams of 10 engineers, something like that, and we were very closely aligned with in mobile. So 20 of us on iOS and Android. So we talked all the time about our processes and tried to follow the same thing and had the same what we call schedule, release train schedule. But we didn't try it in any way to coordinate releases with with what I mean by that is deployments. We would of course try to get our roadmaps aligned, of course, like that, so that things went out around the same time. But we weren't trying to. They were doing like multi they were deploying code multiple times a day, where we as apps couldn't really do that. So the cohesion comes from, so I was a principal engineer, so it was a principal engineer group. So people from every team came and met together and talked about cross team stuff. And then Atlassian has a conference once a year where they bring people from all the teams to Sydney, Australia, where they're headquartered, and just try to mix us all together. We give talks to each other. We go to each other's workshops, and there are platform teams that we have regular meetings that we all you go to the ones that make sense for your part of the platform, so you could hear what everybody else is doing and what parts of products are getting into the platform that you'll be able to adopt. Yeah, so there's lots of little things like that, but
Yeah, no, fascinating. And perhaps a little bit on, and because you shared this, right, which was
Mhm.
post this, right, your journey of writing the book and all the momentous things you went through, including a hurricane and all of that. And
Yeah,
yeah, do you want to share that before we sort of dive in and sort of
sure.
unpack your book? How was
Yeah.
that journey, right? Going about like thinking about the book, right? And we wrote it together in the Useful Books community. And so it's a
Yes.
certain way of thinking about things.
I started in December 2023. So this is how long it's taken me. So it's like 21 months or something. December 2023. I have a blog. I've been blogging for 20 years. I've written for publications. I had just a lot of notes. And I noticed this thing that I thought, like this contrarian take on tech debt, that I had talked about it a little. And then I'd also had these other ideas about developer productivity, and that essentially they were very closely tied. That I think the reason to pay the tech debt is mostly to get the developer productivity. And then you try to layer on these other things like visibility. And I had that general idea. I thought it was a 50-page book. I was going to finish it in 6 months. And so that's what I tried to do. And I joined the Useful Books and a community. I learned about all the things that they teach you there, try to teach the book, talk about the content of the book. And I was doing that with my consulting clients, and I was doing that with my network and on LinkedIn. And I was just starting to find more things to talk about. And I was posting everything online, chapters of the book for free, trying to get feedback. And it got found by the Pragmatic Engineer. And this is a newsletter that goes out to now 1 million engineers, engineering managers, tech leaders. And he asked me to write an excerpt for his newsletter, which I wrote something. We agreed on a topic, we agreed on an outline. I wrote this whole thing, and he did not like it at all. And it was partially because I strayed from the outline. And so he gave me some feedback, and I ended up rethinking about what I would do. And I wrote something totally different. And because what his audience really likes is personal stories. And in my book, I had not thought about doing that much. Like, it was mostly going to be me just saying, like, these things work, these things, and not the stories were not necessarily personal stories. But now I had a lot of words, like these rejected words and these accepted words and all the ones I had written. And I figured out a structure that I would that would make sense. And I wove in my personal experiences at all the places that I've been telling you about, and finding like all these common threads of, like, when you're with a code base, and I had been for 5-6 years at a time, the world just changes. The web gets invented, phones get invented, AI gets it, and it just changes it makes your code base go not be appropriate anymore. And like or like the number of users like goes up by an order of magnitude, or several orders of magnitude. Just things are different. At the beginning, you're looking for learning, and but by at some point you're looking for operational excellence, and like there's totally different problems through a lifetime, through a software life cycle. And that I got firsthand, and I wanted to share that in the book. So I've organize the book in three main sections. One is, you're an engineer, you're dealing with problems, they're right in front of you as you're working. Here are some things you can do. And there's a bunch of chapters about that. Then I think about it from a team perspective. You're a team dealing with bigger problems. You have to have agreements. You have to have budget. You have to have, green light from your management. How do you organize that? And that's where I developed this like way of eight questions to ask about tech debt that helps you find the right plan that's appropriate to the problem. And then the final part is CTO perspective. You're managing teams that might be 4 levels removed from you. You don't have personal experience with the technical debt, but as a tech leader that such thing exists. Like, how do you find out about it? How do you express an overall values around it? And then how do you monitor it from, not by looking at the code, but like what could you ask for from the engineers to help you monitor it? And that's the core of the book. I finished it in the first draft in November of 2024, and I started to work with an editor, and then both of us got hit by two hurricanes. Me in Florida, and he was in Asheville, North Carolina. And a lot of people probably know what happened if they're in the U.S. in Nashville, North Carolina. It was devastated, and so we just had a lot of delays trying to get together and get it through these like several rounds of editing. But I think it was worth it. It made the book a lot better, and then I've just been managing getting the cover written, getting the format to Kindle, and so it's just a lot of things have just take the last 3-4 months. It's been inevitably marching towards the book being released, but I've had to just man. It's almost like managing a project, like a software project, just marshaling the resources. And it went out on November 16th, I think, and so far it's been doing pretty well. So I've been happy with the response.
Yeah, it's been a product launch, right? In some ways, it's
Yeah,
product creation and launch, and I think
yeah.
it's been the top new release. And so, yeah, congratulations on that. I'm very
Thank you.
happy, and and it's so nice that you pushed it through, right? Because when we were writing, I went and looked up the statistics. It's brutal. 95% of people who decide to write a book never complete it,
Well, yeah.
and 99% don't even publish it. And so, you're already top
Wow.
1% in many ways, right? It's
Nice. Okay.
yeah.
Well, I'll take that as a
So,
good thing then.
yeah, no, congratulations on that.
Yeah.
But now let's unpack the insights in your book in sort of
Yeah.
6 steps, like I like to do on this
Yeah.
podcast. So we'll start with save. So there's clearly a wrong way to look at tech debt, which is what you demolished right at the outset.
Yeah.
But like, if we can unpack this further, like why is it dangerous to think that way? How do people
Yeah.
end up sort of, you know,
Yeah.
just
I mean,
because it's
this is what.
easy, right? And so, like, if you can
Yeah.
speak about that, and also
Yeah.
speak about very practical things, because you're speaking to engineers, you're speaking to engineering
Yeah.
leadership, you're speaking to multiple stakeholders about the same topic. So, what are ways they should think about it, and especially
Right.
also, compare legacy businesses with newer
Sure.
businesses.
Sure.
So,
So, I mean, a big part of save is the groupthink, right? That it makes you think, oh, this is just what everybody does. I'll just do what everybody does. Old code it's bad because it's old, right? That's like not necessarily. Like old code can be very valuable. It can have one of the things legacy businesses have a huge advantage if they have code that has been created over time to solve a lot of problems, right? All those solutions are embedded in that code base. And you would not want to lose that by just throwing it away and rewriting it just because it was old, right? Like there might be reasons to modernize it. I'm not against those things, and I talk about all the ways in which I've done that. But you risk losing institutional knowledge that is like embedded in that source code. There are companies like insurance companies that still run on the COBOL they developed decades ago, and people make fun of them. But you know what? They know what they're doing. Like,
a lot of critical infrastructure, right? I mean, all the airports and all of that, like you say, yeah, I mean,
and
there's
again,
just
there
so
are
much.
problems. Like we see the problems that could happen. I'm not suggesting that it's only like keep all your old code, but like there is knowledge embedded in there, and you need to make sure that you preserve that. One easy way to preserve it is not to change it. One of the dimensions I talk about is this risk of regressions, the risk of you breaking what is working. And it's like, is that worth it for whatever you think you're going to get out of doing something? So people ask me like, what should you do with like, no one knows how this works. It works, but no one knows how it works. It's like everyone's afraid to change it. I was like, but does it work? Then, like maybe again, you should learn how it works. I'm not saying you shouldn't, but I wouldn't just rewrite it because no one knows how it works. That doesn't. Again, I think that's a group think wrong thinking about it. You have a huge advantage if you're a legacy company with a long code base, and I think you can look at and see examples of that where people have correctly decided not to rewrite it,
Yeah, I think
and I agree with them.
well, what comes across in what you're saying is also this level of rigor and nuance, right? It's not just this is good,
Yeah,
this is bad, or oh, they did it, so we do it. It's really
right.
very specific to your situation, and you have to. I think it's very important what you highlight, which is that there's just so much tacit knowledge and solutions built into your code.
Yeah.
That even if the context has changed, the technology has changed, a whole bunch of things might have changed. There might be certain things that are
Yeah.
still relevant, and you want to find a way to understand them when you rewrite. You want to find a way to take
Yes.
these along and not throw the baby with the bathwater, right?
Yeah. Yeah, absolutely.
There's always a key sort of insight, a Pareto kind of thing where, with less effort, with targeted effort, you get much higher impact, right? So non-linear payoffs. So yeah, how should legacy business leaders think about, you know, technology and about the sort of legacy code they have
Yeah,
to leverage their unique strengths, right? Which is exactly what you said. There are
interesting.
things hidden, that there is a lot of tacit knowledge that you can really leverage. And I'm sure
Yeah,
there are other things they can leverage. So, how should they go about thinking about leveraging what they already have to win bigger?
right. So one of the things I think many companies who have these code bases have found ways to layer on top whatever it is that modernization is forcing them to do. So, like, yes, you do need to have an app, right? Or you do need to have a website if this is like, like, of course by now, but 20 years ago when they and yes, it is true that the mainframe running some old thing doesn't support that, right? And like you won't be able to do that. We had that problem at my first company. We were a fintech. We wrote DOS software, single user desktop DOS software. But our first movements towards the web, when the web was invented a couple of years after I joined, were not about rewriting everything we had. We could do the right things to put in API layers to what we had, and then build on top of that web interfaces. And it was something that it was a way to get there. I don't want to say it's like quick because it's not. It's like it's just doing the first thing first. Like by now, so that was 94. Right now, this software still exists and it's totally web based. I am sure they, in that time, like a ship of Theseus, this thing has been completely rewritten in modern web infrastructure. But we had a version of it, in 96 when I left, because we were able to put in, leverage all the pricing. Not like, so we were implementing pricing software for foreign exchange options. Couldn't rewrite that. It's an enormous amount of code, but we were able to put it into a library and make it available through a web interface by building a API layer. And I think that's possible as a first step before you think about rewriting it.
So it's a bit sort of like, you modularize and repackage what you already have. You keep the parts that are,
Yeah.
that you can leverage, you can get rid of the rest, and then you can build on that.
Yeah, we have so many technologies that can help you do that. Even if I mean, virtualization technologies, and all pretty much every kind of way of even those legacy ways have added on ways of doing these, like putting a REST API or some API on top of things and keeping it running the way it was. Now, it doesn't mean you won't need to do something, obviously. Like ours was a single user system. We needed to make it, able to be multi-user, but that's small in comparison to totally rewrite it using cloud infrastructure, totally rethink it, the digital rewrite, digital overhaul, buying into the Kool-Aid of like an entire AWS system. Of course, that was not available back then, but even now, if you had to do that, like that was not what I would suggest as a first step.
And
Yeah.
I think what a lot of people sort of do not leverage is a good understanding of what developer productivity is. And
Yeah.
so I think it'd be nice to hear your thoughts on that, because I think a
Right.
lot of
Yeah.
people, people mistake activity, people mistake effort, people mistake optics, people mistake a whole bunch of things and try to deduce developer productivity. But
Yeah.
because you're speaking of resistance, right, you have a very clear understanding of
Right.
what developer productivity is, how to measure it, how to think about it, etc. So
Right.
how should leaders think about that?
So there are three popular developer productivity is so hard. Everyone would reject something like crazy, like lines of code per day or something. No one would think about doing that. Sometimes they pick something that is basically that repackaged into like commits per day or something like that, or and there's a lot of discussion of this, but there's three models that are getting popular, I think for good reason, mainly because they're multidimensional. Like they're just looking at lots of different things. So there's this model called Dora. It's mostly a DevOps model. What I'm going to say just generally about it is, I think it's about it's very easy to use Dora metrics and understand business outcomes from Dora metrics, because it's about things that you can see with the software. So how frequently is it being deployed? How long does it take code to get from being written to getting into production? How often does a deployment fail? And how much, when it fails, how long does it take you to recover from that failure? And those are all things I think that the business can understand. Those are all lagging metrics, though. Those metrics, you cannot move them. You cannot sit down at your desk and go, today I'm going to make deployment failure frequency go down. You're going to have good practices that result in that over time. You're going to find out about it next month, next quarter, whether you've achieved that. But they are still good as a check. Like you should be like, ultimately, again, like, you have to win the game. Like, these things, those things matter.
Yeah,
They're what matters.
the lagging metrics should be reported, right? They should be reported. They should be
Yes. Yeah.
studied, but you cannot build towards them. And
Yeah.
just a funny one, an interesting story here is that I have a friend called Dora, and she's like a data engineering leader. And so like, yeah, we actually spoke about Dora with Dora. So
I
that's,
say, interesting.
but yeah, I think that, so yeah,
So
I think in some ways,
you should definitely have that in your toolbox. But what I have found more useful for tech debt is to have some leading and things you can do. Like, you're sitting down, you can do it. And there's another model called DevX, DEVEX. It's the same people are developing these models, the same researchers, and they're doing it through studying Microsoft and Google from the internals. I think it's very well steeped in research. But what I love about DevX, and I'm going to talk about that very quickly, is that they are leading indicators. There are things that you can do, and I think that I was very happy to see that they are pointing out resistance. And so to me, they tie very well. So one is flow, how long engineers are in flow. And this is just something, like, there's not gonna be a counter somewhere, hours of flow. Like,
there's no thermometer, right? You cannot just put a thermometer.
Right.
So.
You know it yourself. You're an engineer, and you were able to work 4 hours uninterrupted on a problem without a meeting, without being interrupted on Slack or whatever. Like, there are things you can do to make that more happen, like schedule your time, or make sure, no meeting. We had no meeting Fridays at last year. Like, things like that will help. But when you see yourself, here's the thing about flow and tech debt. Tech debt knocks you out of flow. And you see it, you feel it. Like, you start to do something, you can't figure out how to do it, you kind of get frustrated, and then you let a distraction kind of take over. Maybe you go check Slack, you check your email, you whatever, and like, now you're kind of out of flow, and then you kind of get back to it, and now you have to load your brain. You'll see it, like, yourself. And if you can do things to the code that keep you in flow, you're generally going to the kinds of things that fix small tech debt problems, like messy code kind of problems in the small, are the things that are going to keep you in flow, because they're kind of easy. They're kind of like something that, like, starts to get you more deeper into the understanding, and they're the kind of thing that creates understanding. So, like, me adding a comment to a piece of code I didn't understand is me reinforcing that I understand it. So flow is one. The second one is cognitive load. So if I need to know a lot of random things in order to do what I'm doing, and it's not represented in the code base, that is a thing that leads to low productivity. Again, you just know it in your head. It's not up. There's not a scoreboard of how much cognitive load every engineer has, but it's a thing that you should notice. Like, there's random facts I need to know. There's random, like, oh, I had to tell somebody something. It's not written down anywhere. You just have to know it. Like, the more of those things, and the more the code is not helping you know those things, the more it's going to lead to low developer productivity. It's going to eventually move those lagging things. But and the kinds of things you do to fix it are, like, to make the code easier to understand, to reduce the complexity in the code base, to decouple things that are affecting each other that shouldn't. You separate them, and now you don't need to know about A to change B. So cognitive load is the second one. The third one is feedback loops, and this is like we've been talking about this because we're both reading Thinking in Systems, and feedback loops are all of these things that I've mentioned. They're in the small, in the moment. You say, you're going to save a half hour here, an hour there. Feedback loops are killer in software development. Now, the one we see all the time is code review loops. I put up my code for code review. It takes 2 days for anyone to look at it. When they look at it, they find a bunch of problems. I see it the next day, blah, blah, blah. Now we're in different time zones, so add all that. All that. So anytime I'm having to deal with other people and getting feedback, it's frustrating because you will make your estimates based on how much work you need to do, but everyone only cares about calendar time. And this is where you cause these feedback loops cause the biggest mismatch between estimated work time and calendar time, because they're just like weights. They're big periods of waste. And if you write code that is easy to review, right? So then it is much more likely to get reviewed faster, for that review to go more smoothly. If you write code with tests and you've made sure it works, it's much more likely it's going to get through QA without being kicked back. All the feedback loops in the system are improved by code with less steps. And so if you think, oh, it takes me an hour more at the end of this thing to get it right, what is that compared to the 2-day delay in a through code reviews, the kickback in QA at the end, and then possibly the failed deployment, right, which actually shows up on your lagging metric. So it makes no sense not to spend that time if you think about it that way. So that's why I like DevX. It kind of tells you what to do to get this productivity, and then you hopefully will see it with Dora. Yeah, so I think
So
the combination works really well.
yeah, this kind of really this really focuses on the align aspect, right? Because if
Yeah,
I were to draw parallels, right, Dora is a bit like EBIT, right? A lot of very good operators obsess about EBIT, so like increase EBIT over time, etc.
yeah,
But in a business, these are all these are lagging metrics. It does not make sense to align someone to something that is lagging. You want to have a leading metric, especially when,
yes,
as a legacy business, we're in the digital, or in the data-driven paradigm where it's
yeah,
not about physical goods. You don't have a cost of goods sold, and you don't have all these concepts that help you sort of compute profitability. So what you're saying is that DevX should be like, or it is a nice way to think about alignment. And what
yeah,
comes across there is this idea of resistance, and sort of that ties into your sort of,
yeah,
redefinition of what tech should be seen as, but also the fact that feedback loops and sort of a systems kind of way of thinking is important, because even if you fix the individual things, the system can sort of be inefficient and can be
yeah,
slow and be expensive because of this. So
right.
with this, you've kind of actually covered the idea of alignment, how to achieve
Yeah.
alignment, and the distinction between leading and lagging
Yeah, if I
metrics,
could say
which
more on alignment, I think a big part of, and I talk about this in the book, is alignment is something Commander's Intent you talk about in your book. It's very important, like, giving the general values for how we deal with tech debt in our company. But another thing I think is important is budget. It's like tech debt, I think, is one of those things that you kind of want to time constrain. You don't want it to just grow without bounds. So you want, as a leader, to get people to spend the right amount of time on it, you want to give them a budget that they must spend on it. They can't overspend on it, but they also shouldn't want it to be underspent. So I think a big thing that helps teams understand what they should do is you're expressing that commander's intent with like a budget that helps them understand the scope of problems they should be attacking.
how do you define that budget, Lou? Is that money?
Yeah,
Is that time? What kind of, how do you think
it's
you
going to
call this?
ultimately be money, right? But often it's a person, like how many what percent of the team is doing it. So again, it totally depends where your product is on its adoption life cycle. So like startups at the very beginning, new companies, they might not be spending a lot of time dealing with this because they're constantly throwing away things. They're just trying to find product market fit. Where it gets kind of interesting is more like, again, with legacy businesses. You have users, you have a roadmap. You might be in the growth phase, like a rapid growth phase. You might be in a operational excellence phase where like it's more of a cash cow. It does really well, but it's not growth. It's not where you're seeking growth, but you do need to maintain this. This is what's funding the rest of your bets. And where you're looking more for operational excellence, it might be that budget might be higher because you might be finding ways to improve your running costs, and you might be finding ways to simplify things in the beginning of at the beginning. They may have been hard, and you might have had to invent, but now are commoditized, right? And I know you talk about the dangers of accepting commoditization, but of course, if they are available and you are staying in the business, you do want to use them to get your costs lower.
No, I
It's just
think
not
I
where
think
you
you
should
should.
concentrate all your effort, right? Like,
Yeah. I just mean you shouldn't commoditize yourself as a business in your market, but of course, you should use the best thing available out there.
yes, often long-lived code bases often have things that they had to invent at the beginning are now available much cheaper on the market. This happens in technology, of course, all the time.
Hmm.
And so you do have to think, and a lot of that work is, I'll call, tech debt kind of work. Like the world has changed, and now your code base needs to adopt those. But you're going to get some. There is some not leveraged ROI, but some ROI to be gained there. And that helps you save money, and then it's also helping to simplify the systems that you have, right? Like to pick the next thing, like you want your systems to get simpler over time if they're successful, because it should be the case that if you that the world is giving, inventing tools and commodity tools for you to take advantage of over time, not at the beginning, but 60 years, 10 years, decades into it, it should be the case.
Yeah, this simplify step is just so important. I mean, it's come across time and again in conversations, and because especially in legacy businesses or traditional sectors, but in basically any business after a certain point in time, it's just the nature of problem solving, of
Yeah.
the error correcting mechanism in any
Yeah.
organization that that ends up in an increase in complexity. And
Right.
the costs of complexity then can accumulate, can really bring
Absolutely.
you down. Many ways this idea of like complexity being a problem, being a drag, is very much aligned with your idea of like swimming against tech debt, right? And that
Right.
at the end, it's all about reducing the drag. The idea
Yep.
in Simplify is really, how do you get rid of the drag? Because
Yes.
it's this judgment of knowing what is slowing you down and what is it you want to keep. And a lot of it is through modularization, right? Which is that,
Yeah.
if you pack, I mean, you can't destroy, just like you can't destroy energy, you cannot destroy some level of sophistication somewhere. You can just package it differently. So,
Right.
what are your thoughts around this, around simplification and as an executive priority? Because there is no bottom up
Yeah.
process that simplifies. Bottom up is complexity. So you need to sort of,
Yeah.
go top
Yeah.
down on
I
that.
mean, only the leaders, I think, can decide to remove successful things that are just not moving the needle. That is something that is very hard for people down at the bottom to decide to do. But it has a huge effect on the simplification of a system. Probably during the lifetime, you have found edge cases that were interesting, right? And you made money doing it, and maybe that was good. Like I've worked at places where it was all about the edge cases. We were all about the edge cases. But at some point, it might not be worth it to keep them going anymore. Like they might not be like they might be what's holding you back from operational excellence and simplifying your system around what you have now found to be like the main, what you're the main thing that you should be doing. And it's hard, but I feel like only the leadership can do that, is to decide like we might need to not support this set of users anymore, and it's okay. And if doing that, you're going to be losing some amount of money. So like, but if doing that results in a great simplification of the system and better support of your ideal users, such that you can grow that even more, maybe there are many, many more of them, and maybe that edge case is a declining market. Um, uh, that will help simplify your systems very much, and your engineers cannot decide to do that. They can only possibly tell you through internal usage metrics, like where are good places to think about doing that. But that can only come
Yeah,
from leadership.
yeah, definitely. And I think, like you said, it's all about the trade-offs, but that has to
Yeah.
be an executive decision, and
Yeah.
it has to come from the top, which kind of brings us on to the next step, which is optimize. And I was
Yeah.
really like, right at the outset when you were describing your way of thinking, and that,
Mm.
this is not about someone taking taking shortcuts that ends
Mm.
up in technical debt. That's a nonsense way to look at this, because,
Mm.
if you should take a shortcut when you want to go from point A to point B in the fastest way possible, right? But the fact that technical debt is fundamentally born through trade-offs that are made at a point
Mm.
in time in the past, and that
Yeah.
today, with what you have learned, with the way the environment has evolved, with the tools that are available, etc., you would now make different decisions, right? So
Right.
if I were to characterize, I think, and correct me if I'm wrong, but like my understanding is that you're saying technical debt is you making the best possible decision at time T1, and that now at time T2, you would look at it
Right.
differently. And at time T3, you would look at it again. And so that is the way to think. That's the
Yeah.
way to think about technical debt.
Yes, and it might also be the case that even if you knew totally time T2 and T3, that the T1 was still the best decision, even knowing that, because I don't want to cop out and say it wasn't inevitable, but it's just like it was the appropriate spend to the problem that you had. If you had tried to solve the T3 problem at T1, you might not have survived. You might not have
Yeah, it's the
gotten it done.
resources, right? It's the
Yeah, yeah,
resources, it's the market, it's a lot of these other
yeah.
factors that are outside your control.
One thing that's I think this is obvious once I say it, but like technical debt is only a problem for successful projects. Unsuccessful projects like don't have technical debt. They are deleted. So like honor the decisions that were made along the way. They in retrospect were correct to some degree. Like they had some good effects. Like you are successful and now you have these problems. Great. That's much better than you don't exist, right?
Yeah, I think this is something that's so true in investing. You have someone, who has had 2 good years and then they go, oh, but my returns are X%. And then they try to benchmark with someone who's been around for 50 years, right? And I go like,
Right.
oh, okay, how about you wait
Survive.
50 years and we see if you're still around, right?
Yeah, 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 exactly. So what I wanted to say from what so you will have this idea T3. A really important step is write that down, write that down. I talk about this idea of like make sure you document and publicize within your team the target architecture, the target best ideas. Because what's going to happen is it's going to be like a pulling force. While I'm working, I will see opportunistically times when I can do that. This gets back a little bit into commander's attempt, but it's a little at the team level, right? Like so we are saying as the leads, right? This is our target. If we could rethink it all from now, if we could throw it away and instantly have it rebuilt for us, this is what we would build. Again, this is the bridge that you're supposed to blow up, right? Like or whatever. Like this is the goal. You're going every engineer is going to have a time when they can make a step towards that goal and they're opportunistically going to do that in while implementing the short-term roadmap. They're going to take steps and you're going to get pulled there over time. That happens a lot in stuff like technology migrations. Like I'll talk about like in to technologists, like there's this system called Angular, another one called React, and a lot of people used to use Angular, but now they would rather it be React. And there's ways to migrate there over time. And if we know that's the target, well, when I'm sitting there looking at this Angular code, well, let me as a first step, you know, if it seems reasonable and appropriate to the size of the problem, rewrite it in React and take the steps now in the moment where it has the best effect. It's helping me implement the feature I have to implement.
Yeah, which I think makes me think about this idea of sort of developing an empirically valid view of the world that allows you to make optimal decisions.
Yeah.
And really optimal has got a big asterisk on it because,
Yeah.
it's really very, very contextual. There is no formula here to say, oh, this, that's extremely contextual, but this just even this attempt to think about it that way and to be rigorous about thinking that way, I think is valuable. And
Yeah.
so what are your thoughts on how engineers, but also engineering leaders and business owners should sort of think about this empirically and optimize and, sort of develop
Yeah.
this capability?
So, yeah. So just to get back to what I was saying, like if you could in the small, using these leading indicators, doing it at the right time when you're feeling the resistance is the optimum time to remove that resistance because otherwise you might remove resistance that you might never encounter. That's kind of
This
the problem. Like our anticipation of what we might encounter might be flawed, and then it would be wasted time. So
This reminds me, if I may, this reminds me what Luca Delana said to me on my other podcast,
Mm.
which he writes in his books about, is that problems only get as big as you allow them to grow. So,
Right.
if you nip them early enough,
Yes. Oh,
right?
for sure. I definitely think of tech debt as a thing you're constantly dealing with, and then so that would help you in the small. What you also should be doing is, your product managers, a very common thing is to have a now, next, future kind of like quarterly, 3-quarter roadmap. You're going to have to supply estimates probably for those ideas so that they can prioritize them. this is where you would be looking. And there are tools that can help you through a code-based analysis, give you an idea of what debt you might encounter. So I would be doing a step where you're taking the roadmap plans, like the things that they would like to do, and trying to anticipate what resistance you might find if you go there, either through experience, through code analysis tools, through trying to do pilots, like, okay, you're going to want to do this. Let me spend a day trying to do it a little and see what happens. And the purpose is to encounter that resistance so that you can now feed back in the estimation process, like what the true cost of something might be. And then also now you have time possibly to deal with it because it's coming. This resistance is like you're going to do. So now you can do things to like get rid of it just before you're about to encounter it. Not like, oh yeah, we might do this, but like you're gonna do it. Like next quarter, they're gonna definitely do this. It's already been greenlit. Let's clear the way. Let's do some clearance of the way. So again, I think if you use this concept of resistance, it is, and apply it this way, you're gonna end up hopefully optimally paying tech debt that you would have caused a developer productivity issue if you hadn't gotten rid of it.
Yeah, and which also goes to prove that your framing of this is way better than this, paying back a loan kind of nonsense,
Right.
right? Because that's, if you have the wrong framing of the problem,
Yeah.
then the optimal solution for that wrong framing is a horrible solution. While if you
Yeah.
have the right framing, even a somewhat okay solution to that problem,
Right.
right, will still be a better solution overall. Which kind of brings us really to the whole point of all of this, right? Which is growth, which is about abundance, which is about seeing opportunity and not sort of tunneling down. Because when you're constantly problem solving, when you're constantly fighting your way through the forest of your market, of your business, of life, of whatever, then you end up sort of having that tunnel vision. And the idea is really to get rid of that and see all the opportunities out there. And in that context, I think if I could ask you two questions
Yeah.
from two different perspectives, right? So how do you so the engineer is swimming against this current of water, which is transparent and is, really struggling and sweating. So as a business leader, how do you get your engineers to kind of see beyond their sweat and their effort and see the big picture and build that empathy and obsession for the customer and get them inspired to think about that? And the other way around, as an engineer, when you were really sweating and struggling, how do you get that message across to your to the business owners so you can achieve, you can both to work towards growth?
Yeah. I was lucky to be at a lot of startups. And in startups, the engineers have no separation from customers. They often have to go on early sales calls. They're often dealing with support calls. It's just a very common thing. I think there's a new term that's getting very popular with like a forward deployed engineer, very close to the customer. That startups do that all the time. In a lot of ways, the part of my book that's for big organizations and maybe more legacy organizations, successful organizations, is to somewhat replicate some of the things that are working in the small, but trying to do them in the large. Another thing that happens at startups is you have direct access to the leaders like all the time. Like I'm having lunch with the CEO and the CTO all the time. See, they are constantly. I'm getting through repetition the values of what we're trying to do, what our customers are seeing. They're just telling me all the time. I'm having lunch with the head of sales all the time. Obviously, this does not happen as you get bigger and bigger and bigger, but you need to try to replicate this. And at Atlassian, I could tell you some of the things that could played this role somewhat. I think a lot of companies try to do it. A lot of companies will say they do it. I think Atlassian did a pretty good job when I was there. One is like our values are, we had 5 values and they weren't just lip service when I was there. They were very well ingrained in how we work. People repeated them to each other in conversations, like as a way of as the way of coming to this. Like I very rarely ever saw that in my career, where like someone would use a value statement to make an argument in a discussion, and that happened to me all the time at Atlassian. For example, be the change you seek was a very common thing. And when someone was frustrated by not being able to get something done, like we tried to give them the idea of permission, like you have some permission to do it, with be the change you seek, like use that little bit of permission to show us the way. And people, and there are other examples of that. They also, a lot of places would do this, and I think it's really important. Skip level meetings, and those happened to varying degrees. I had 4 or 5 levels between me and the CTO, but I met with my manager's manager, my manager's manager, like on some cadence, lower each for, but they would find out from us, about tech debt problems, and then be able to orchestrate across the whole company. But more importantly, like maybe we would hear strategy, like big strategy stuff directly from them in a way that we could ask questions against it, and then understand it better. They also did a good job, especially at the product level. Our Trello management did a great job of, in our all hands, telling stories of what was happening to the rest of us, that where they were showing how the value in action was uh, getting the result that they wanted. So like by recognizing something that was happening and publicizing it to the rest of the group really helped. And so I think there are things like that. There's more than that, but like there are ways that where you can get that customer attention. Another thing we did was we had a customer support person sit on our backlog grooming, and we would always ask them, like, what are we on this list, like what would our customers, like what are they complaining about, so that we would have some idea. So there's
And the
all
nice
kinds
thing
of.
today is, a lot of these textual stuff, right? You can really, very quickly now get summarized. You can sort of,
Yeah,
surface issues. And so it's just so much easier.
there's
That's only
ways to
by
get
abundance.
data from unstructured. It used to be super hard to take like 10,000 customer support emails and get some kind of data from that. That
And
used
now
to
it's
be
one click.
impossible.
And now it's one
Yes,
click, right? That is
right.
amazing.
And it's easy to tie it back to double check. And I used to like hand tag things coming in just to have like some evidence. Like when I see this problem, I just want to tag it, like so I would later be able to show some database evidence that a problem was real. Now I could get that for any new thing without manual work. Think people definitely should take advantage of that. If you have a huge customer base, you have a treasure trove of support cases where you can
Yeah,
find. There's
100%.
a
I
lot of
think
value to find.
as a legacy business now, you just have so many opportunities to
Yeah.
obsess about your customer that, for example, a startup can't really, because they don't have customers, right?
Yeah.
That's why they're a
I will
startup.
say they also have this thing that I think is really important in this AI obsessed roadmap, AI driven roadmap obsession. So they have a set of problems that were voiced before there was AI, right? So they have, if you look to those, what are these perennial things? Instead of saying, "Oh, AI can do this, let's just stick it in our let's stick a chat bot in our thing to whatever easy thing you could do with AI," right? Instead, look to these big perennial problems that have always existed in your system, that that were impossible to solve before AI, and what AI is giving you now is the solution to a problem is valuable. Because that problem wasn't made up during this time when we were, using this AI solution to find the problems for us, where like we're just looking at the things that we see in other systems. Like, yeah, summarization is a thing it can do, and chatbots are a thing it can do, but does everything need summarization, chatbots? Those those have their place, but like
Yeah.
what's the thing that your customers value? You are much more likely to know that if you're a legacy business than a new
And as a
entrant.
business leader
Yeah.
today, right? Meaning like,
Yes.
earlier you had to work with engineers, you needed resources to analyze, to surface, to unpack these things. Today, as the CEO, you can really be like, hey, give me a dump of all the conversations as a TXT file, right? And then you can
Yeah.
already start engaging with that. And I think that
Yeah.
and yeah, and I think that on that note, I think there's just so many opportunities and so much
Yeah.
abundance available to grow. But it's
Yeah.
not where everyone is usually, it's not where the
Yeah.
herd is running.
And then let me say one thing about how tech debt could lead to growth.
Mhm.
If you are in your system doing the kinds of things that tech debt will drive you towards doing, like getting to a target architecture that is built up from simple systems being composed, you now have the capability to compose them in new ways. You have a library of useful components that you've built up over time that are encapsulating this legacy knowledge, right? And if you have done it in a way where they can be reconfigured, you're now able to apply them to new problems that are 80% like the old problem with this new layer or this new delivery mechanism or this AI, let's say, assisted part. But you can't get there if your code is locked in a high cognitive load, complex system that hasn't been simplified, hasn't been separated into modules, hasn't been put into a nice architecture. Something that you allowed to aggregate over time that you never went back and fixed. So there's huge opportunities to the companies that have taken the time to do that, to apply that to new problems.
Yeah, I think that's a brilliant way to sort of summarize this, right? Which is, you know, kind of reframe how you think about tech debt
Yeah,
and reduce the resistance over time, and then you'll be a much faster swimmer. And
yeah,
yeah, get a copy of Lou's book. This is, I think, I think it's a very important contribution, and I think it's going to have ripple effects in a very large way because,
thank you.
um, yeah, because this like challenging non-rigorous conventional sort of approaches and ways of doing things,
Yeah,
and then is in itself an edge. And then if you act on it, I think it really allows businesses to do that, to win in their market. So it was a real pleasure to speak with you,
yeah,
Lou.
you too.
Thank you
Thank
for
you.
stopping
Thanks for
on
your
Slack
advice.
Talk. Yeah, leaders are readers. And yeah, do grab Lou's book and apply the ideas. That's the whole point.
Thank you. Thank you. It's so great to talk to you.
Thank you, Lou. If you enjoyed this conversation, make sure to subscribe on slasog.substack.com and on YouTube or wherever you get your audio podcasts. See you on the next episode.